Hello everyone. In preparation for our long test, I'll be giving you more examples related to our lesson in Module 1. Example number 1. Convert 315 centimeters to meters. So of course in the exam, you're allowed to look at the summary of conversion factors. So all you need to do is to find first or identify what quantity are you trying to use here, whether it's length, mass, volume, area, temperature, time. In our end here, we are dealing with length. So look at length, and then afterwards, you have to identify the system where it belongs. cm and meters, both of them belongs to metric. So your attention must be here, only under length, and then metric to metric here. So to solve this, write 315 cm, and then of course our goal is to convert it. It must be cancelled out. So the cm must be in the denominator. So you have to look for cm in our conversion factor. So cm is here, and looking at it, meters is on top. So we're gonna pass through cm to decimeter, from decimeter to meter. So cm to dm first, and then afterwards dm is not what we want at the very end, so we put the dm here in the denominator, and finally we have meter. So looking at our conversion factor, 1 decimeter is 10 cm, so here, and then 1 meter is 10 decimeter. So finally, we can cancel out the cm and the dm, and what is left is the meter. And that's what we want. So in other words, 315 times 1 times 1 is 315. 10 times 10 is 100. Then you have meters here. So 315 divided by 100 is just 3.15 meters. And this is our answer. So we now proceed to our B. That's 1.5 kilometers, and then we're asked to convert it into meters. So first of all, this 1.5, it would be better if we convert it either in decimal or in mixed number. So in our end, I will be converting it into a mixed number. So how to convert it? 2 times 1, denominator times the whole number, added with the numerator. So 2 times 1 is 2, plus 1 is 3. And then copy the denominator. So 1.5 can also be considered as 3 halves because they're just equivalent. So now, we put 3 halves here. And of course, kilometers is now in the numerator. So we wanted it to be cancelled out. We put kilometers in the denominator. And afterwards, you can look at our conversion factors from kilometer. Then you look for a way to change it into a meter. So kilometer and meter is here. So we have to pass through hectometer. And then hectometer. Okay, hectometer should be converted into decameter. And then decameter to meter. So, looking at our conversion factors, 1 kilometer is 10 hectometer, 1 hectometer is 10 decameters, and then 1 decameter is 10 meters. So, kilometer, hectometer, and decameter will be cancelled out already. So, that would just be numerator times numerator times numerator times numerator. 3 times 10 times 10 times 10 that is 3,000. Then 2 times 1 times 1 times 1 is just a 2. 3,000 divided by 2 is 1,500 meters. So this is our answer. Let's proceed to our example 2. Example 2 is all about time. How many minutes are there in one day? So first, it's all about time. So you find the quantity for time, it's here. And then you're converting days to minutes. So you must pass through hours, then hours to minutes. So write one day here, and then you put day in the denominator. Okay, convert it into hours, and finally, then hours to minutes. So in one day, there are 24 hours. In an hour, there are 60 minutes. So, day will be cancelled out, hours will be cancelled out. So you have 24 times 60. That would be 1,440. Then minutes. Let's proceed to example 3. In example 3, this is temperature. So the formula is already here in our conversion factors. So again, this is an expression if we try to connect it in our lesson in algebra. So all you need to do is to use the correct formula. In A, you're asked to convert 50 degrees Fahrenheit to degrees Celsius. So that would mean that you're converting Fahrenheit to Celsius. And the formula is Fahrenheit minus 32 times 5 over 9. So the given Fahrenheit is 50. So you need to follow PEMDAS. You're supposed to subtract first. That's 50 minus 32. That's an 18. Then you multiply 5 nines with 18. So actually, 18 divided by 9 is 2. So that would just be 2 times 5. So 2 times 5 is 10 degrees Celsius. Okay, we proceed to B. We're converting Celsius to Fahrenheit. So the formula would just be degree Fahrenheit is equal to degree Celsius times 9/5 plus 32. So the given degree Celsius is 40. Follow PEMDAS, we multiply first 40 with 9/5. But 40 divided by 5 is already an 8. And then 8 times 9, that's already 72. Then you add afterwards, you will get 104 degrees Fahrenheit. So that's our answer. So 40 degrees and 100 degree Fahrenheit and 104 degree Fahrenheit has the same temperature. Okay, let's proceed to example 4. Bea has 2-liter bottle of juice. How many glasses can it fill with 210 ml of juice? So to solve example 4, so first of all, we have to convert 2 liters to ml. We need to convert at the first place because the glass is in ml. So they must have a uniform unit. So 2 liters. Okay. Liters is all about volume. So you go to volume. Liters and ml are both metric. So your focus would be here. So you're just converting a metric to a metric. So liters is here. ml is here. So I mean L liters will be converted into deciliters. Then deciliters to centiliters, and finally centiliter to milliliter. So liter in the denominator so that it will be cancelled out. Liter to deciliter, deciliter to centiliters, then centiliters to milliliters. So looking at here, that's the path, okay, to reach liter to ml. So 1 liter is 10 deciliter. So just focus here, your attention. Then 1 deciliter is 10 centiliters. And then 1 centiliter is 10 milliliters. You cancel out the liters, the L and CL. And what is left is just ml. So 2 times 10 times 10 times 10 is 2000 ml. And then, after doing this step, second step now is to divide 2000 ml with 210 ml because one glass is 210 ml. So, 2000 divided by 210, if you do long division, you will end up with 9.52 for that. So, we're asked about number of glasses. So, the final answer here is Bea can fill in. By the way, the meaning of the three dots here, like that, it's like a end of the triangle. It means therefore. So therefore, Bea can fill 9 glasses with juice. So why is it that it's only 9, not a 10? Because the 10th glass is not filled. We're not able to fill in it with the juice because it's just half of it. Okay, probably half of it or approximately half of it. So it's not counted. So what we want to know is the number of glasses that are really filled in with the juice with the 210 ml, and it's only 9 glasses. So this is the answer. Let's proceed to example 5. Here, a horse runs 120 kilometers in 3 hours. So first, we are asked to find its average speed. Okay, speed in terms of formula, speed is just equal to, okay, that would just be distance over time. And the distance of this horse is 120 kilometers. And the time is 3 hours. So 120 divided by 3 is it's 40 kilometer. The fraction bar means per hour. Or we can write it as 40 kph. Now in B, at this rate, how far does it run in 2 hours? So, to get the answer, you just have to multiply 40 kilometers per hour. Okay, that's how we write it in fraction. And we just have to multiply it with that time. So, speed times time. Because what will happen if we do that? The r's will be cancelled out because this is in the numerator, this one is in the denominator. So what is left is just the kilometer or the distance. So 40 times 2, it's 80 kilometers. Okay, let's proceed now to C. How far can it run in 20 minutes? So that's the question. So first, we have to convert 20 minutes to hour. We're converting it into an hour because our speed is in hour, not in minutes. So they need to have a uniform unit as well. So we write first 20 minutes, then minutes to hour. 1 hour, 60 minutes. So minutes will be cancelled out. Then 20 over 60 is just 1/3. 1/3 hour. Okay, so to find the distance, again, it's just the speed times the time. Speed is 40 kilometers per hour. We multiply it with 1/3 hour. Cancel out the hour, so you have 40 over 3. So if you just write 40 over 3, since this is already a real life problem, 40 over 3 would somehow be difficult to understand. That's why you need to write it in mixed number so that it would be understandable. So 40 divided by 3. Okay, don't forget you just have to do this. 40 divided by 3, that's 1. 1 times 3 is 3. Subtract 1, bring down 0. Then 10 divided by 3 is 3. 3 times 3, 9. Subtract. You'll get 1. So in other words, that would just be 13 and 1/3. 13 is from here. 1 is from here, remainder. 3 is the divisor. So 13 and 1/3 kilometers. Okay, now let's proceed to example 6. For example 6, it says that the fastest land mammal, the cheetah, can run at 70 miles per hour. So, yeah, mph is miles, and then we're asked to convert it into meters per second. So, as a solution, 70 miles per hour is just 70 miles per hour. So don't forget mph is not meters per hour. That's miles per hour. So you put miles, then fraction bar h in the denominator. So first, we need to convert miles to meters. So look, meters and miles are both length, and meters is metric, miles is English. So we look at English to metric here. So there. So look at the connection between miles and meters in here. So we have, okay, perhaps we can convert miles to kilometers first, and then kilometers to meters. So we put the miles in the denominator, then kilometers on top, and then finally kilometers in the denominator, then finally meters on top. So according to the situation here, that 1 mile is 1.61. But you can also consider 1 kilometer is equal to 0.62. You will get the same answer, so no worries. And 1 kilometer, you have 1,000 meters. So we cancel out the miles, then the kilometers. So what is left is just meters. Our next concern would be the R. should be converted into seconds. So in the same process, ours is in the denominator, so we also put ours in the numerator so that it will be cancelled out. Then, seconds in the denominator. In an hour, there are 3,600 seconds because it's 60 times 60. 60 minutes in an hour and 60 seconds for a minute. So the hour will be cancelled out already. So you have 70 times 1.61 times 1,000. So if you simplify that, okay, the numerator would give us 112,700. Then don't forget you have meters on top. Then denominator you have 3,600 seconds. So we divide that with 3,600. So approximately you'll get 31.31 meters per seconds. Okay, now let's proceed to example 7. So the smallest mammal, the bumble bat, is 1 inches long. How long is it in centimeters? So we're converting English to metric and its length. So looking at here, okay, we already have an inch to cm. So we just have to use that. So we put 1.1 inch here, then inch in the denominator so that the inch will be cancelled out, cm in the numerator. So take note, 1 inch is equal to 2.54 cm based from our problem in here. So cancel out inches. Then 1.1 times 2.54, that would just be 2.794 centimeters. Okay, let's have our last example, example 8. So an elephant can run 35 kilometers per hour. About how many kilometers can it run in 6 minutes? So our speed is 35 kilometers per hour. And supposedly, to get the distance, we just multiply the speed times the time. The problem is, our time is in minutes, but our speed is in hour. So we still have to convert 6 minutes to hours. So 6 minutes times, we put the minutes in the denominator so that it will be cancelled out. And then hour in the numerator. In an hour, there are 60 minutes. So the minutes will be cancelled out. What will be left is just hour. 6 over 60 would just be 1 over 10. So afterwards, to get the distance that the elephant can cover in 1 over 10 hour, multiply it with 35 kilometers per hour. R will be cancelled out. 35 divided by 10 is 3.5. So this is the answer. Okay, that's it. And God bless.